Okay, I'm back. Just finished my advanced class, my students, and sent them off. It's now 10 p.m. So I started this paper today. It's the exam paper, Paramount Unit 1. My students did today, 2014, and I have already done some of the questions that the students asked me to do. These are the already been done, and they are on the channel. And I jumped to number 6 because they also wanted me to do number 6. I did 1, 2, 3, 4. And I jumped to number 6. I took a break to do my advanced class. And now I'm coming back to start back with number 4. I'm going to do number 4 and number 5 before I depart. All right. Let's go. That's a vectors question, number 4. It says a plane P passes through this point and is perpendicular to this vector. That's a normal to the plane. It says show that the equation of a plane is this. All right. So let's call this point A, so we can reference it. And the equation of a plane is of the form r dot n equals a dot n, where a is a position vector of a known point, referring to that. N is a vector that is normal to the plane, which is that. And that's the premise on which we're going to find that, that equation of the plane. So they want us to prove it in this form. And the r represents a general point, because I want it in the Cartesian form. I'm going to write the r as x, y, z, like this to begin with. I'm going to use a column vectors for the purpose of the calculation, and then write the answer in that format when we're done. Well, it's going to come out in that format anyway. Then the normal is this vector. As column vector, it will be 3, negative 1, 2, no, negative 4, 3, negative 4, 3, negative 4, 2. All right, 3, negative 4, 2. That's the vector equals the vector for the A point will be 5, 1, negative 3 from these coordinates. Doing the scalar product again with the n, which is 3 minus 4, 2. This is simple calculation. When I do the scalar product on this side, it's 3 times x is 3x. Y times minus 4 is negative 4y. Z times 2 is 2z. And then what does the right side work out? 5 times 3 is 15. 1 times negative 4 is negative 4. Negative 3 times 2 is negative 6. So this remains 3x minus 4y plus 2z. And this becomes 15 minus 10, which is 5. We have a 5 on this side. We transpose it to get a negative 5 on that side, which is what they have. So let us just do that now. Minus 5 equals 0. That is it, shown. All right. This part says, calculate the angle in radians. They want it in radians between P. P is a plane up here. This is a plane P that has this normal. And another plane with this equation. So the angle between two planes is the angle between their normals. The angle between two planes is the angle between their normals. So the normal on P, let's call it N1, is going to be the vector that they gave us up here. 3 minus 4, 2. 3 minus 4, 2. The normal on this plane, let's call it N2. We'll have these values 7, negative 4, 3. 7, negative 4, 3. That's how we can pull the normal from the Cartesian form. I'm going to explain why now. It should be known. All right. And the angle between the two planes is going to be the angle between those two normals. So the angle that we want, theta, is cos to the minus 1 of the scalar product, which is n1 dot n2, over the modulus product, modulus of n1 times the modulus of n2, two normals. That's our calculation. What space do we have? All right, a bit. So our angle becomes cos to the minus 1. What is the scalar product? Multiply the 7 by the 3. 7 3 is 21. Negative 4 times the negative 4. 4 4 is 16. Positive 16. And then let's write this 2 better. And then this 3 times this 2 is 6 plus 6. That gives us the scalar product divided by product of the modulus. Let's come with the square root. And the first one, the n1, it's going to be 3 squared, 4 squared, 2 squared. 3 squared, 4 squared, 2 squared, times the square root. The other modulus is 7 squared, 4 squared, 3 squared. 7 squared, 4 squared, 3 squared. And just to get my angle, I'm just going to put everything in the calculator as it appears here. I'm not waste any time. All right, so let's get the calculator. I'm going to put the calculator in radians first, which is already in radians. You can see it there. And I'm going to put these values in there. All right, let's make it a little bit larger. So let's see it. So I'm going to put cos to the minus 1. It's a fraction. I have 21 plus 16 plus 6. Putting that over the square root. And then the square root, I'm putting, well, 3 squared is 9. Plus 4 squared is 16. Plus 2 squared is 4. And I'm going to put another square root. And 7 squared is 49. Plus 4 squared is 16. Plus 3 squared is 9. So in radians, that is 0.3. Later, that's a number of decimal places in radians. That's all I wanted. So I'm going to give 3 significant figures, 0.381 radians. I'm going to put that for the symbol on radians. That's it. That is it. Right. That is it in radians. Let me see what in degrees what I would get. In degrees, 21.8 degrees. Right. But that is it. 0.381 radians is the angle between those two planes. And between two planes is the angle between their normals. All right. That finishes that part. This part down here says the equation of a circle is this one. We want us to determine the center and the radius. So what I'm going to do is write this in the standard form. This is a general form. So the standard form is x minus a squared plus y minus b squared equals the radius squared. When it is in this form, the AB is the center and the R is the radius. R is the radius. So what I want to do is form those perfect squares from this. All right, so how much space do we have? Always have to be checking space with these things. All right, what does happen here? Okay. Not a lot of space, but we can compute the square of these. So I'm going to compute the square of these two values. And so I'm going to let's do it in purple. So I'm going to write x squared minus 6x plus y squared minus 8y minus 39 equals 0. So what I've done, I've placed the x terms together and the y terms together so I can compute the square. Compute the square of these two, I'm going to have x minus half of this is 3. And the square, subtract the square of this value. So subtract 9. That's how I compute the square. For these two, it's going to be y half of this is negative 4. Put on the square. And then subtract the square of this 60. The square of that 9 is 16. The square of that 4 is 16. And then I have minus 39 equals 0. So now I have x minus 3 squared from here plus y minus 4 squared from here. And I have minus 9 and minus 16, that's negative 25. And then minus another 39. All right, so that's minus 9 minus 16 minus 39, 64. That negative 64 goes on the right side as positive 64, and 64 is the same as 8 squared. 8 squared, 64. So these form the coordinates of my center, 3 and 4, because it is now in this format. So my center is a point 3, 4, and my radius is equal to 8 units. And these are my answers. Written right. All right. This is an environment we should do questions all the time. Quiet. It was noisy in the office, but I just wanted to do it. The question, that's how it is. I might redo it when I move sterile environment. Those videos that I posted earlier. But anyway, such is life. So determine the equation of a tangent to the circle at the point 11, 4. I'd like to make a sketch so we can have a visual of this situation. So I'm going to sketch a circle right here. And the center of the circle is 3, 4. Right here. 3, 4. And the point 11, 4. But have the same y value as this. It's right across here. 11, 4. And so you have to be smart because it means that your normal is a horizontal line of the same y value. It's not requiring a calculation. This is a normal horizontal line passing through 4. So your normal is a line y equals 4. The tangent is going to be vertical and pass through that same point, like so. That's going to be a tangent. And the equation of your tangent is going to be x equals this x value. X equals 4. X equals 11. X equals 11. Let's shift this a bit. Maybe x equals 11. The vertical line passing through a point 11. That's it. Don't need to calculate. It says determine. Don't need a calculation. I'm going to use the diagram as my reference. All right. Since the y value here is 4, that the point is 4. And normal is a horizontal line. A tangent is vertical. Horizontal lines carry an equation y equals a number. That number is a y value at the points that pass through. X equals a number is the equation of a vertical line. And so because it passes through the point 11, 0, 11, 4, equation is x equals 11. And so we can basically write the answers here. It's writing values. So determine equation of a tangent. So from the sketch, don't need any calculation. From the sketch, the tangent equation is x equals 11. What is it? Calculation needed. 5 marks for that. Wow. Paper wasn't difficult, man. Getting 5 marks or something like that. When a situation like that, this can be tricky to persons because they go work out the gradient of the normal, they're gonna get 0, but calculate it the normal way. And the gradient of the normal will be 0. So the gradient of a tangent, which is negative reciprocal, is going to be infinity. You have to know that if the gradient is infinity of a vertical line. The situations like this don't really require any calculation because it's very obvious. All right, so it is that next part. It says a point Q moves in the xy plane such that it is equidistant from this point and from that point. Determine the locus of Q. This is another easy question. We'd like to have this point A, and we have a point B, and we have the locus here, which is xy. And locus, we're going to give it coordinates P, and A has coordinates 2, -5, and B has coordinates -2, 3. Don't mind where I place the values, right? Don't mind where I place the points. It's just a schematic of it. Or should I put it the right way? But I don't put it the right way. I don't put it relative to each other. I put it the right way. -2, 3 would maybe be up here. The B, -2, 3, maybe be like up here. The B, -2, 3. And the A will be like 2, -5, more like over this side. A, -2, -5. And then we're going to place P anywhere, right? We can place the point P here, for example. And give it coordinates XY. Then we put it at a place where it can be shown to be equidistant. So we're going to say this distance is the same. I don't want to look like a perpendicular. Let me shift this over a little bit. Put it here. This is equal to this distance. That and that equal. All right. So if that is the case, this distance equals this distance. And that's the premise on which you're going to calculate the locus and the locus. I'm going to say AP is equal to BP. What is AP? AP is the square root. The difference in x squared using these two, right? Difference in x squared, so it's x minus 2 squared plus y minus a -5 becomes y plus 5 squared. Let's shift this down a bit. All of this. And that becomes equal to BP, which is the distance between these 2 points, which again is the square root of x minus a -2 becomes x plus 2 squared and y minus 3 plus y minus 3 squared. And then we square both sides. We could literally leave off the square root, you know. We could put the square on this and put the square on that. And then leave off the square root like this. We're going it that way. And then we are working this out. So technically we have the locus right here now. We might want us to simplify it. And we can know looking at the number of marks sometimes how much work they want you to do. But really and truly, if you give them this, you're supposed to get your marks. They will always say simplify to lowest terms. So let me expand it out and simplify it down. Because really and truly, it's supposed to get a straight line. It's going to be on a straight line there, the perpendicular bisect of the line between them, really. So we could have also calculated the perpendicular bisect of the line between them. That's the locus. We're going that way, right? It's going to move on a line, which is the perpendicular bisector between them. So we could have calculated the perpendicular bisector between these 2 points. Get the answer. So let's get that. Let's work it down to a line. Since we know it's going to be a line, let's work it all the way down to a line. So I'm going to expand on the left side first. I'm going to get some gymnastics, you know, can subtract something and difference of 2 squared and simplify it. And I bring this over here and subtract with that. And bring this over there and subtract. Now let's do the y. Bring this over here and subtract. Set up the difference of 2 squares. Take this over here and subtract. Let's do it that way. You must like big people. I'm going to put y plus 5 squared minus this y term. Y minus 3 squared equals x plus 2 squared minus this one. X minus 2 squared. Now this is now the difference of 2 squares. So it becomes this minus that. Watch now. This term in here minus this term in here first. So it's y minus y gone. 5 minus a negative 3. Give me 5 plus 3 is 8. That's in the first bracket. Times the sum of this and that. So y and y is 2y. And 5 and minus 3 is 2. Equals. That's the difference times the sum, all right? We're going to do the same thing here. Difference of 2 squares. In the first bracket is this minus that. So the x minus the x that gone. 2 minus a negative 2, give me 2 plus 2 is 4 in the first bracket. Then I need the difference. I need this plus that. No, I need the sum, this plus that. So x and x is 2x. And 2 and minus 2 is 0. We're just getting that 2x. All right, so if I simplify this 8, cancels this 8. All right, so I can write 2y plus 2 equals x. That's it. 2y plus 2 equals x. I feel like I want to check the perpendicular bisector method and see if I get this as well. Let me just check it quick. So the midpoint between these 2 points, let's check it quick. The midpoint, if we bring it another way, the midpoint is called the midpoint M, right? Yes. Just to do it another way quickly, M. So the M is going to be, midpoint is going to be the average of the x values, which is this and this. It's going to be 0, you know, 0. And the average of the y values, this and this, going to be negative 1, because that's 3 minus 5, negative 2, negative 2 over 2 is negative 1. The midpoint is negative 1. Then the gradient between these 2 points now, the gradient, right? So the gradient between those 2 points, the gradient equal the difference in y by difference in x. So it's 3 minus a negative 5, 3 plus 5 is 8. divided by -2. -2 is -4. The gradient becomes -2. So it means then that the gradient of the perpendicular bisector is a negative reciprocal of this, which is a half. And this is really a y-axis intercept, So this is really easier. So the perpendicular bisector, which is the locus. The locus is the perpendicular bisector. Right? The locus of Q is the perpendicular bisector of AB. Let me shift some of this down. So leave that solution in here as well. Okay, shift this first. Shift this now. This will become an OR method for right. So I get the same answer because this is a y-axis intercept, really the M. This is the gradient of the perpendicular bisector. So the gradient of perpendicular bisector becomes y equals this MP x plus c. And we have a c. So it becomes y equals half x plus 1. If you look at this equation, it's the same thing. Because if I multiply 2 by 2, the same equation, right? And this, I mean, why the subject? I'm gonna let my plus 1 and minus -1. -1, 3 minus 5, -2/1 is -1. -1 mistake. The point is -1. So this is a -1c and -c. -1. Okay. That's it. So transpose this and make by the subject. We're gonna get this finished off 2y equals x minus 2 divided by 2, y equals half x minus 1. So I think recognizing that this is the perpendicular bisector, I mean, this way might be an easier way, it doesn't matter. What is it? So we'll work this way as well. I'm gonna leave that on the screen. On the page, we have to draw that perpendicular bisector for the diagram. Drawing the diagram, too much of the diagram. The locus is perpendicular bisector. This is the locus, that 9. Into the midpoint that we call M. All right, that's what we call a perpendicular bisector. Of M. Perpendicular bisector is this line. We point to this. I'm just setting it up so if somebody gets the document, they'll understand, right? So that's what I'm trying to do here. So I'm going to point it from here. Perpendicular bisector is that way. All right, so that's it. Question is done. I think this one's a very easy question. Whole of this one. So person should have gone through this one. So I'm going to end this one now, and I'll do the next one in the next video. And then I'm going to leave this place, number 5. I'm going to end now and start back with number 5 in the next video. See you then.